everything to do with networking and content delivery. Today, we have a bunch of experts from the content delivery edge side and some exciting stuff for you on JA3 and client TLS fingerprinting. I'm gonna let the guys introduce themselves, maybe starting with Alex, and tell us where you're based, what your role is,
Oh,
what's your
sure.
expertise.
Greetings. Hey, my name's Alex Menning. I'm a senior solutions architect here at AWS, and I work in the edge technology space, including perimeter protection. So I got about like 18 years CDN experience, and I've been defending, protecting, and accelerating many of the brands you know and love on the internet. So it's good to be here, and I'm joined by a couple of my other colleagues on. We're going to talk about an interesting solution we've been working on. Anybody else want to pick up?
Cool. Alex, how long have you been in AWS?
Oh, I've got like I just made my 2 and a bit marker, so 2 years and a bit. But previous to this, I had worked at a couple of the other larger CDN providers in the ecosystem, and some of the little guys. I've got a knock background, or like I came from like ops and made my way into the front end of the problem. It's CDN and delivering stuff online, or CDN and security has just been an infinitely fascinating, aspect of my career. That the dynamic conditions that we're in, like trying to deliver stuff online and then accommodate emergent technologies or emergent persistent threats. There's always something to do on the internet or around content delivery. Yeah.
Awesome. And funny enough, we just realized that I think we worked for the same content provider in the past, and we're in the same office, just sitting on different floors. So.
Yeah. Yeah. It's a very small world, the internet delivery ecosystem. Again, I am honored by the colleagues that I've worked with in the past, and I'm happy to be here at AWS. Trying to offer insights, solutions, and deliver value for the customers.
Cool. Awesome. Maxim, you want to go next?
Yeah. Hello, everyone. My name is Maxim Akifev. I'm a senior product manager in AWS WAF, which is a web application firewall, part of perimeter protection services. I've been with AWS for about 2 years, and I'm based out of Seattle. And before AWS, I worked for multiple startups, which vary. Worked in payment gateways, worked in authentication startup for a while as well. And just as a background, I started as an engineer and made my way to product management over time. So I'm a little bit technical too.
Nice.
Fair.
So as a product manager, so you decide what goes into a service, right? So you control which features WAF is going to get. So if people want a feature, they need to talk to you, right?
That's what I'd like to say, but it's a little bit more complex. We got other stakeholders like our engineering and marketing and sales people that we have to consult with.
Yeah, always a balance. Cool. Alexander, last but not least.
Hello team, happy to be here. My name is Alexander Glovati. I'm Senior Technical Account Manager, working closer to customers based in the Bay Area. And actually the chain is built in a way that customers come to me for the features. I reach out to Maxim, and if we can't figure out what to do next, we bring Alex to the conversation.
Fair.
So that's a good SWAT team here.
Nice. So we have all the brain power pretty much here for anything we need in terms of edge and fingerprinting, I guess.
Yep.
Awesome. Yeah, and for folks that are just joining, yeah, we actually had a little bit of a mishap last week because this is a weekly show, and last week we had issues with our streaming keys for Twitch, so we actually had to cancel. So apologies for those who were trying to join, but I'm glad we were able to sort it out, and we're back online, and we have a super interesting session for you today. Cool. So with that, Alexander, we're going to pop some slides, but I know you guys also have a demo plan for us, so I'm super excited about that.
Yeah, there's two, and I would probably ask Alex to help here to cover the global infra and do a little bit of introduction to the edge services AWS.
Yeah. I mean, so just starting at the basics, right? When we think about, what AWS, like what our services are built on, right? which is, we've got this like highly redundant, like multi-terabit infrastructure, which links all of our regions and our connectivity with our backbone. So it's this highly resilient architecture that we build our services on, right? And here, you want to go to the next slide?
Yeah, sure. Yeah.
And so, when we look at like a picture, what that means for CloudFront, right, which sits on top of the global network, right? The name of the game is trying to make the internet fast, reliable, and secure, right? Where how we do that is by bringing the connections, the content, and the experiences close to the end users by being in network or close to the end users. And we do that for all the names you know and love, right? And a lot of our like core capabilities are deeply integrated into the CDN or into our content delivery network, which sits on top of this network, right? The key capabilities, right, when we think about like what CloudFront prioritizes, it's availability, right? That's kind of table stakes for a content delivery network, which is where we're terminating requests for end user traffic and where your end users go for picking up content, and also like gives us a great opportunity to filter, scrub, and protect infrastructures behind CloudFront, which would be your regional infrastructure, your ALBs, your NLBs, your any of the kind of regional infrastructure. But the CloudFront itself is a global construct, which sits on top of the AWS network. And yeah, it allows that performant experience by bringing the SSL termination and the content close to the end users. We offer a bunch of different capabilities. Here's a couple that are highlighted, right? I mean, again, the name of the game with CDN is always be caching, ABC, right? You want to cache and accelerate your content and bring it closer to the end users. One of the great powers of the CloudFront platform is the edge compute functionality, where we have a number of different flavors, but the two primary ones that people will leverage is Lambda at Edge, which is applicable to the 4 areas you have to interact with the cache, which is on the viewer request, viewer response, origin request, origin response areas. Functions are our lighter weight framework where we allow for some compute capabilities on just the viewer side of the cache. But the whole notion of bringing termination or SSL termination out to where the end users are and the content ultimately out to where the end users are is the name of the game of CDN. I mean, there's some other capabilities we could go into, but when you're trying to build a resilient architecture on the platform, you'd leverage CloudFront with that. And there are some unique headers and capabilities that CloudFront has by being in the request chain. One of those is what we're going to talk about with an advanced solution that we put together, leveraging JA fingerprints. So JA fingerprints and other header signatures can be leveraged in chain with the CDN. We can append those to the origin request or use those in the edge compute frameworks, which is what we're going to be talking about today in leveraging the solution we put together. So with that,
Alex,
yeah.
Before we move on, just we're talking about HTTPS applications, really, right? That's where CloudFront really shines. Protocol it really delivers, right?
Yeah, I mean, these days, there is some HTTP still left around, but in my abundant spare time, I'm also spending some time working on the Web Almanac, which does like a crawl and a report of the top sites and provides some deep analysis of like what sites are offering. And again, it's the vast majority of requests these days are over port 443 and our HTTPS connections. The SSL Everywhere and the good work of our friends over at Let's Encrypt have really like empowered the community to get cheap and efficient SSL certificates everywhere. Of course, with CloudFront and with ACM, you get free certs with the platform and a deeply integrated cert capability to get TLS certificates. But yes, functionally, what we're talking about in this solution is the the fingerprints that happen during the initial connection with the platform that can be leveraged for classifying and characterizing the different kinds of clients that connect.
Gotcha.
So yeah.
Yep. Thanks, Alex. And I think very important is to shed some light on the history, how we evolved the service and what we offer to customers. Because apart from just giving the header order, header count, which work very well, you can basically allow list very specific clients for the very specific application, just by specifying which headers you expect, in which order you expect. Also, we went ahead and added the HTTP version. That's a header which is forwarding the version you're using, where you can enforce the specific version at the edge. Moreover, the step forward was taken with CloudFront Viewer TLS header, where this is an example when you do connection over TLS 1.2, and the very specific cipher was selected during the negotiation. You can add an extra logic at the edge when you kind of reroute the request with TLS 1.3 to some other place, or you can enforce a very specific cipher to be allowed. There's multiple things there, but back in November 2022, we have this CloudFront Viewer JA3 fingerprint header added. So what's happening in the background behind the curtains, we calculate the fingerprint, we add it at a header value, and that's where you have a capability to technically forward this header to the origin itself and build the logic either on the application and or invoke Lambda at the edge and play with that specific fingerprint. That's what we did today. Moreover, the interesting piece, and that will be covered in our first demo, is that all of this is working for Quick Protocol as well. So that's where we shine.
So I got a quick question. I got a quick question, Alexander. So just to make sure I get it, and maybe folks in the viewing us get it. If you go back to the previous slide, so I'm connecting as a client. I land on CloudFront, and then CloudFront will calculate a bunch of headers based on the information on my connection, and then pass those headers back to the origin so we can do some actions on those. And previously, because the header order, so is CloudFront going to tell me what's the order of the headers, or is CloudFront also going to be able to order the headers in a certain way? Or is it more just tell me what the order of the headers are and the count? It's just informational data about the client connection.
Yeah, here, I can take this one. So yes, it's going to give you the specific header order in the connection. But what you bring up is an interesting point, which is CloudFront also has the capability to normalize headers or to manipulate the headers moving in and out of the cache. And so as a request comes by, we're characterizing and classifying the connection, right? And that could be the TLS fingerprint or the JA fingerprint, as we're going to talk about today. But that's also characteristics of, how I define some of these other headers is there's like TLS fingerprints, but then there's like HTTP fingerprints. And so the header order and header count, I'd classify those as like, more towards like the HTTP semantics, or like how the, the header order is presented initially to the CDN. And with that, again, the clever part that you can do with some of these is that user agents like Chrome or Firefox or connected TV devices will, present very specific patterns of how they do, say, their accept headers, or what, because there's some more esoteric headers that are very common in the browser ecosystem, which are pretty effective ways of classifying the traffic. And sure, an adversary could try to mimic those, but they change Chrome version to Chrome version, or version of the browser to a different version. And with that, you can have a really clear way of identifying things that look different. And so with that, you can do some clever applications for security.
Okay, super interesting.
Got it. Thanks, Alex. Thanks for taking that. And I know we had this conversation. It's like a lot of discussions. Hey, what we going to present? Like what use cases? Because there's numerous. It depends on the customer. But the rule of thumb is that IP addresses, and when we deal with like blocking IP addresses, identifying them the old way we used to do at the edge, it can increase the blast when we try to disengage the malicious requests, right? JA3 is not. That's the core benefit here. And it can help you tracking the client fingerprints and identifying simple automated bots, some browser extensions, multiple things. And how we do calculate it, I would like to just jump a little bit ahead in favor of a time to present more rather than talk. Technically, all we care about is only this TLS client hello. So all of the data we take, we do calculate at the edge. We take it from the data presented by a client. Now, what is the data we take care about? Of course, it's defined in RFC. There is a multiple things you could measure on, but ciphers, list and order of extensions supported, elliptic curves, and elliptic curve point formats. Now, there is multiple changes like in RFCs, like the recent redaction, the elliptic curves replaced with supported groups, but it doesn't change the idea. So at the end, your capture will have JA3 full string. These are the values defining all of these connection parameters. And at the end, JA3 itself is MD5 hash from this specific value. Now, MD5 make it impossible to decrypt back by its nature, so you can decompose it and dive deeper, which is bad for us and good for the humanity. But that's not it. I mentioned quick protocol. I mentioned this HTTP3, and definitely we follow the evolution here. The whole handshake is happening for HTTP2 in one way. In HTTP3, we rely on the data transfer using UDP. We use connection identifiers when we establish this very first handshake. So it's a lot of difference. Yet for you as a customer, it will work seamlessly. So you will have the same JA3 fingerprint presented as a CloudFront header if you enable it, or you can go to your WAF logs and grab the fingerprint from there. So it's really transparent for a client, no matter which protocol it files back to use at the end. And why HTTP3? Well, it's publicly available data. By end of July, we expected to have like more than 33% of all of the clients around and all of the critical applications running on HTTP3. And it does have its own benefits. Maybe someday in the future, we'll do a separate session just on HTTP3. It's super interesting, by the way. But we decided to bring you some demos specifically on how the fingerprint is taken from this quick protocol negotiation. And it's an easy piece here. You can go to CloudFront. You can enable both or just enable support of HTTP3. And then technically take a capture. And let me switch back to my console.
Alexander, before you jump to the demo, we do have a few questions in the chat here.
Excellent, yeah. Perfect.
So I want to bubble this one up from Zenjubers, which I think moves to a bigger question. So uniqueness of the TLS parameters. So ultimately, how uniquely are you getting identified with a JA3 hash? Right? Is it per client? Each individual client will be different, or are you going to a level of, I know this is this type of browser and this type of connection, but it's not as unique as a client? So what's the level of granularity based on the parameters that I've seen? I don't think it's the level of a client. It's a little bit broader, but curious to hear what you guys think.
Here, I can take it a little bit, which is, so historically, this was like when we were looking at like how the JAWs calculated, right? It's these like the cipher header order and the, low level TLS connection, right? And so when we think about that, like what influences that for a client, it's the OpenSSL libraries and the, how the TLS is being negotiated on the client and what its preferred cipher lists and, those aspects are going into the signature itself. There have been some changes, right? So what you could identify with a JAWS fingerprint is it's the user agents like SSL libraries that they're using, which don't generally change too much in between like requests typically previously, meaning there's been like this change in the ecosystem where it's kind of like a cat and mouse game in between the the browsers maintainers and them not wanting providers to use this for malicious purposes or tracking outside of the context of security. And so our friends at Chrome or our friends doing the browser maintenance have introduced like entropy effects, or they've tried to like make it harder to leverage this technique to identify session over session, right? So the notion is like, yes, it allows you to identify individual clients when they're in the non-browser ecosystem, because TLS versions or the TLS libraries that people are connecting in generally don't change that much. In the browser context, we get it at the session, right? Because each session they flip and swap and try to mess around with the order and mess us up. I don't know. That's my understanding of where we're currently at. Did I characterize it correctly, or you got any more other color to add?
Yeah, we actually can mention that to uniquely identify a client, you would need to go with GA4 for sure. It actually, instead of taking into account the supported extensions and their order, it just takes into account the extensions itself. So it allows you to identify, no matter how the browser rotates this extension order, it allows you to identify it with more precision. But for GA3, there is a way to address this problem as well. They call it GA3 normalization, where the accuracy rate is over 99%, but it's not embedded into the AWS capabilities here. It's a little bit beyond the scope of this meeting. To answer your question in more details, it will allow you to identify very simple clients with no permutations, with specific connection parameters like specific TLS version. So, other words, any hard-coded stuff, usually it's used by bots or by some tools. You have the statics fingerprint. It won't change too much. And I don't want to take it deep on GA4. We have Maxim for this. Just please let us wait till reInvent and dive deep into more interesting insights regarding the fingerprint.
Got it. So would you say, so if the way to think about it for JA3, or I keep calling it JA3, I don't know if that's actually correct, or
I call it JA.
Yeah. So would you say it's kind of like we can't trust the user agent because it's so easily spoofed, that this is kind of a way to get a little bit of extra trust, so that hash is kind of like a more trusted user agent? Would that be a fair way to think about it? Or is it even closer, so I can than just the user agents?
It's fair, but let's put it this way: the whole goal, you can't win this war. It's endless, development of the hacking tools and protection tools. All we can do is basically to increase the cost for attacker, because they need to have a separate fork of OpenSSL. They need to be able to rotate the ciphers, change all of this stuff. It becomes very expensive comparing to the regular bot attacks, the volumetric attacks. So GA3 will help you to cut the volumetric, and everything which comes to much more complicated logic, it needs an extra protection layer, which we will have during the reInvent presentation.
Yeah, I mean, the other way you could think about it, or the way I like to think about this, is just another signal that we can use to classify traffic and help us identify traffic for perhaps additional treatments. So that's when I'm looking at logs to try to understand like what's happened in like a scraper use case or an account takeover use case. I'm looking at the fingerprints to kind of get a feel for the distribution of different kinds of agents, right? It's another tool we use to classify the traffic and try to understand what people are trying to do on the implementation.
Got it. Yeah, and we have one more question here from Dominic about prerequisites, but I'm assuming this is going to become a little bit clearer as we go through the demo because it's probably just enabling it, right?
Yeah.
Cool. Okay.
Well, I mean, maybe we could just add a little bit more color on that one, which is so. So when we say prerequisites to use the JA3, right? We talked about it earlier that it's depending on how you want to leverage it, right? So like in CloudFront, right, you enable the headers to go forward to the origin if you're going to use it in origin logic, or you'd enable the headers to use them in your Lambda edge logic. And so there are some prerequisites to use them. So yeah, that's when I think about it, it's like what you need to do is just enable the header if you're going to use CloudFront to leverage this capability to go forward to either the edge compute solution or your origin infrastructure. Of course, we log all this stuff too, so you'll see these in WAF logs and in the queries that I work on for Athena when I'm picking apart stuff. I'm oftentimes looking at the JA3 to try to drive some insights of, again, what group of requests this is in.
Cool.
Yeah.
Okay.
Okay, let me try to do some magic stuff here. And what I will do first is run the packet capture.
Alexander, you may want to zoom in because my eyes are bleeding.
Can we get the command plus a bunch or just a little?
We will for sure.
Enhance.
Let me do this. Yep. A little bit more.
Yeah, it looks great.
Excellent. And I'm trying to hit my endpoint, my CloudFront.
Same thing for this window.
Same thing. Yep, that's a problem. So what I did here, I hit my CloudFront endpoint. I do have Elastic Load Balancer behind it with HTTP 3. On the CloudFront end, I have enabled the HTTP 3 itself.
You want to mention what quiche is, Alexander?
Yep, just give me a second. Okay, running multiple screens is very hard.
Yeah, and Alexander had to, for folks watching us, Alexander had to sacrifice, and he's actually on VPN as well. So if we start losing him and he starts becoming choppy, it's because he's on VPN to make sure these demos work.
It's a bad habit. Never do that. Yeah, Tom, you asked the question. Sorry, I missed.
So I saw quiche in there. The most folks probably are familiar with curl, like the tooling for accessing sites. What is going on with quiche? Why can't we just use something?
So it's an excellent question. I know I'm being a bad Amazonian by using third-party tools. It's just rebuilding the curl embedded in my operating system is really hardcore, and I need to follow our corporate security best practices. So that's why I didn't deploy the separate fork for curl supporting HTTP 3 specifically. So I'm using the third-party quiche tool written by Cloudflare and just using it to send the HTTP 3 request. Now we sent the request. We had the packet capture running, and it's running for a while. Wow, I have a lot of packets, so it will be a little bit hard for me to to open it. Let me do that. Yeah.
Oh yeah, I think we're starting to hear the VPN challenges.
Nothing like a live demo.
I'm sorry for this. So this is my capture. What I will do, I will go and follow the UDP stream. It will be
you might want to zoom in there as well for us, because that's... You must have a very big screen, Alexander, because...
No, I have very good eyes. Not the screen. Okay, looks like this capture is not very... So there is a way how you can find out where the... Yeah, so we had a couple of connection attempts using HTTP 3. These are the crypto sections. So I should have them visible here, and that's my ultimate goal. It's just we have too many protocols here, and let me just reopen it from scratch, or even better, I do have the slide showing how the negotiation looks like. My ultimate goal is to share how to use the HTTP3 functionality from the CloudFront perspective. So all you need to do is to go to your CloudFront distribution and technically edit the settings and enable the HTTP3 there. Once we enabled, these are the headers, by the way. Yeah, I will cover it later. Once we enabled the support of HTTP3, we can, here, it's enabled. We can accept the HTTP3 connections. Now, there's two ways on how you can get the value from your fingerprint. And one of them is go to your WAF if your distribution is protected by WAF WebACL and check for the value of the fingerprint.
I think the more things you
enable,
open, the harder you're straining the VPN, Alexander, there. We might have to get you to jump off the VPN to continue.
Got it.
Because if you manage to do the capture, I don't know if you will still need to have the VPN connection. I guess for other things, you might need to jump back on.
Yep. This is my fingerprint from my connection attempt. This is the so WAF successfully calculated this.
Yeah, Alexander, I think we need you.
This is
to
the
jump
way how
off.
to get it.
You got to jump off that VPN for a second because it's we'll see if things are going to improve. Fingers crossed. You might have to reconnect.
Oh,
yeah, there we go.
Oh, you're back.
Here I am. I'm so sorry for inconvenience. Yeah, but that's the fingerprint of our request, right? And I crafted my query to login sites in order to see the user agent as well. So this is my quiz, and I'm able to take the fingerprint. So next connections coming from some client, some like third-party client, open source client, I can just allow this, or I can add it to like a list of restricted fingerprints and do many fun things with that. But the key focus of the demo was a little bit different, and the capture file is big, I get it. So let me just go back to the demo. And I have this slide. That's what would you see when you do the packet capture. You would see this initial communication sent, the handshake happening. So on the first round trip for the quick negotiation, you will have this destination CID and source CID. This is connection IDs helping HTTP3 protocol to track you. So the whole idea when you lose connection, like I did just recently, you drop off from VPN, your connection is still going. You have this connection ID and you're not bound to source IP and destination IP like we do during the regular TCP handshake for HTTP2. Now that's given. So here is the handshake, right? Here's my first step. And in the crypto section, we have the same handshake protocols, hello, right? This is a client hello, sorry. We have the same client hello. And that's where we take these values from. So in a similar way, like we calculate the JA3 fingerprint for the regular HTTP2. Now for Quick, it's interesting piece because Quick itself, it does allow to have the fingerprint built on server hello as well. And since you connect to an edge, it is actually a fingerprint of our edge services. So they've been no use to customers. That's the reason we provide only client fingerprint, because it can be reused. So that's the first piece. That's a benefit we provide. So we support the fingerprinting for all supported protocols. But there is a problem, and we already scratched a surface in this problem, on this problem of evading the fingerprints. And the core thing here is a browser extension permutation introduced by Google. And Google intent was to solve completely different problem here. What it result in is that now we have to use this TLS fingerprint normalization in order to identify whether it's Chrome or any other browser. And every time you reconnect during the new TLS session using Chrome browser, you'll have a different fingerprint. And that's for a good reason. Like we can, again, I'm just sharing it because you can take it, use it, and better to complete it on your own rather than just go through the demo probably. So on my Mac, I just run the packet capture, did it the same, sent 5 requests to 5 pages. And within one TLS session, I have exactly the same JA3 fingerprint, right? The next time when I run the same request for the different session, the JA3 fingerprint will be different, and for a good reason. And the reason, as we mentioned, is that the browser extension permutation come into play. So we have this number responsible for listing all of your extensions, and these numbers are just shuffled here after the browser extensions were changed automatically. And these are the factors impacting on JA3. So if you specify your connection curl --TLS v1.2 or v1.1, whichever version you specify, it will impact on JA3. Whichever cipher you specify explicitly, it will also impact on JA3. And of course, there's a separate fork for OpenSSL allowing you to shuffle extensions in the way browser does. So that's why the JA3 is probably not a silver bullet. And that's where GA4 comes into play. And GA4 is very interesting. I just recommend everyone to dive a little bit deeper to that and try to learn, because there's different types of GA4. There's a server side, client side. There's multiple things you can measure. And again, the whole benefit here is that instead of listing the extension codes, it lists just the number of extensions. So we do not care about the order. All we care is only about the number. You can check the protocol version. You can check the TLS version. From the application settings header in your TLS handshake, you can get the HTTP version. For Quick, it will be H3. And here, instead of TCP, it will be U, because Quick is basically utilizing UDP for data transmission. Interesting piece about JA4. And don't get me wrong, it's not supported yet by AWS, but just to give a full picture where JA3 is useful and what's the next step is probably we need to cover it as well. And if the ALPN side has 2 zeros, it indicates that the client is not a web browser. And if you expect all of your client connections to come from the real users, and you don't want any automation of hitting your, I don't know, subscription page or just some restricted area on your website, you can reuse that piece of GA4 fingerprint as well. That's a little bit deeper than we expected. And in order to close this gap, and again, as Alex mentioned, it's just a signal. We do recommend to use JA3 fingerprints along with HTTP fingerprinting headers and our WAF signals as well. Maxim, and finally, word to you. I'm really sorry, it took a little bit more than supposed, but yeah, you're welcome to cover the WAF piece as well, because it's very interesting to look how it works together.
Yeah.
Sorry. Yeah, well, Tom, there's actually an interesting question in the channel. Can we try taking that one about the machine learning model to do jaw
Yep.
fingerprints?
Yeah. I was waiting for kind of a good spot to bubble that up because it's a I was wondering if you guys do anything in that space to try and kind of use AI models to try and figure things out with JA3.
Yeah,
Yeah.
I can take a pass on this question.
Please.
And I'll give you a short answer and a long answer. As usual, when you talk about machine learning, there are different variations. So in this case, I think it's possible for you to create some kind of model that would look into different variations of fingerprints, comparing it with your baseline of valid JA3s and see if there's any difference. But the problem with this approach is that it's so difficult to keep it up to the date. It's a game where bad guys are always trying to be one step ahead. So in this case, you can try to build this solution, but I would also recommend to use additional request metadata to enrich your solution. And for example, header order is a very powerful tool that will give you more information about the request. And you would also want to look at additional request metadata, such as user agent, the IP it's originated from, and some specific headers, like a session ID, cookies. So yeah, to close on this short answer, you can definitely do this, but I would recommend to use more request metadata to give you better results. However, if you're looking for a simpler way to achieve the same outcome, we do it for you. If you're using bot control managed rule set with AWS WAF. So with AWS WAF bot control, we employ some additional techniques to identify if the request is legitimate. And it also uses machine learning to perform an analysis of those requests and identify if those are requests coming from real clients or someone is trying to evade detection. And ML models is just one piece of the puzzle that we're using. But really an important benefit of using a managed solution like WAF bot control is that it's constantly being updated to keep up with the threat landscape. So we release different versions of bot control where you get additional visibility into the traffic. And we also use challenge and capture. And probably everyone already knows what CAPTCHA is, and it's a very popular tool to confirm if the request is coming from a real user. And challenge is more like a headless version of CAPTCHA, where you would silently achieve a similar outcome. But in this case, it would be your browser that would execute the code and generate a token. And based on this token that was generated as part of a challenge request, we would perform an additional analysis and we would be tracking it as user is going through different pages. So for example, it would generate a token and then we can see if user is reusing this token multiple times, which is actually a very important step because sometimes we hear that the CAPTCHA solvers and other techniques to bypass it. But what usually they would do, they would generate the token and try to reuse this token in multiple requests. But it's important to check for how many times this token was used. So yeah, I think I went pretty deep on the machine learning piece. But it's a very interesting topic, and there's a lot of ways how you can improve your detection. But the bottom line, it's very hard to keep it up with the way how threat landscape is changing. Even in the case I mentioned it with token reuse. You can create your own rules that would check how many times a particular token was used. But again, malicious actors, they would just try to reverse engineer the logic that you have set up. So it's just a matter of time when the solution becomes outdated. And just to expand on bot control within WAF, and just to provide you some idea of how it works with a CloudFront. By default, you already get certain visibility into your traffic with a CloudFront, but it works much better when you integrate it with WAF, because WAF adds an enforcement function to certain requests metadata that you have. So, for example, you can easily set up rules that would check if certain headers are present, and if they don't present, you can serve requests with a captcha challenge, or you can block it immediately. Or instead, if there's certain headers that you know should be added to traffic that you expect, you would allow listed to make sure that legitimate traffic is always going through.
Yeah. Maxim, I mean, I just wanted to follow up on this point just a little bit, though, which is, yes, you can develop your own model, right? Yes, I've got customers who do that. Leveraging the WAF security automation framework would be a great starting place to, get some telemetry, get some signals, and then develop automations to populate block lists, or to, leverage these signals to try to develop your own training on, the corpus of like your site. We've got like these discrete capabilities in bot control, and especially around our targeted bot control, which can give you additional telemetry and signals. In fact, I've got a lot of people using that client session ID in very clever ways to throttle the token reuse. But in bot control itself, we've got these capabilities where we can identify volumetric session reuse, or a lot of value is added by leveraging the native solutions we have. But you can augment that with your own strategy, and be more nimble if you'd like to. So like you can get the best of both worlds. It just depends on, really, how incentivized your adversaries are, and how incentivized you are to, develop and maintain and, work on a strategy around preventing that kind of fraud and abuse on your endpoints. So Maxim, I just wanted to at least there's like, it's like a choose your own adventure, right? Like you can, you could do it in CloudFront, right? You could develop your own Lambda edge code. You could take in the Java fingerprints and header orders and do it all in CloudFront, but I wouldn't recommend that. So like, then there's like WAF, right? Just WAF is just negative filtering, right? Looking for negative patterns, which has a bunch of capabilities around rate controlling and throttling ingress traffic as it comes into your origin infrastructure, which we have a host of automation frameworks and capabilities that you can tune and kind of, really take it to the next level if you want to. But we also offer some native capabilities for, that we maintain that help identify this kind of abuse on an endpoint infrastructure. And so it's kind of like a choose your own adventure. We've got a lot of different building blocks and ways to, secure an architecture. So yes, you could develop your own model, but I recommend you give ours a try first, right?
I always recommend to customers not even like think about some model, but the core step is to identify the baseline of legitimate request, how good requests supposed to look like, and then build up all of your prevention steps based from here. And you could use all of the AI ML capabilities on analyzing your WAF logs, do some retrospective, and catch all of these trends. One important thing, and Alex, thanks for mentioning it. I know that Maxim is really closely working on these new features, and there was one from ATP. Strangely enough, the ATP signals account takeover prevention. If you enable it, you have some somewhat similar signal to what we're trying to achieve with JA3. So in a nutshell, AWS runs some internal database of known bad TLS fingerprints. And if your endpoint is being hit, if someone tries to log into your application protected by ATP from the client matching this suspicious TLS fingerprint, you'll get additional extra signal for this as well. So you kind of match the good things from all of the worlds. And that's why just single fingerprint is not a silver bullet. Again, you need to use WAF in front of it. You need to cope it with the bot protection signals. And that's technically what we try to do in our solution. And I'm sorry it took so long to present. So idea is, you probably know that AWS recently released a longly awaited improvement to our rate limiting rules, when we allow our clients to rate limit by up to 10 requests per minute. Thing is that we do have some recalculation windows still, and in real life you have it like maybe blocked after 20, 25 requests. And sometimes your solutions, like let's say account creation, under what conditions you would expect 20 requests coming to create your account, like 20 posts request attempts against your API gateway? I don't think so, right? So you would probably need some more for granularity, and that's where we came with an idea that, hey, we can actually unite those two tools, use the AWS WAF rate limiting capabilities along with API gateway usage plan. And the whole idea was simple. What I will do, I will probably try to run the demo and hope this time it will go a little bit better.
You don't need a VPN for this one?
Yes, exactly. I don't need it. But what I need is to refresh my session. Give me a second, please. I'm really sorry. It takes some time sometimes, but it's worth trying. And here I am, federated. Now I need to refresh a bunch of windows, but I'm ready to this. So a little demo of what we propose to do if you are not happy with the granularity of AWS WAF. There's many things you could improve. And technically, I have the, let me cover this first. So the solution itself, I went to our workshop, the standard Edge Services Immersion Day workshop. And if you have your technical account manager, ask them, they will be happy to drive this immersion day with you, or you can ask Alex for help. We have a bunch of people ready to help you here. I went to preparation section and took the CloudFormation template and deployed it in my environment. You're ready to go. You have your CloudFront distribution. You have your API gateway, and that's a ready sandbox for you to play and deploy the similar solution. What was done here? So we mentioned that these are the magic headers. And if you create the origin request policy, right, we have the cache policies, you can specify the response headers. In case with CloudFront forwarding the JA3 fingerprint, it's done on the origin request step. So I went to the policy, added the necessary headers. Bear in mind, for this specific demo, X API key needed to be added as well, because we will be playing with JA3 fingerprints and API keys. As a backend, we use the API gateway here. Let me refresh. So what we do in a nutshell, this simple idea of taking JA3 fingerprint and rewriting the API key value with the fingerprint. And what's the benefit? So on the API gateway side, for the very specific stage, for the very specific method, you can define a usage plan. And this usage plan will be bound to your JA3 fingerprint, which means for client who bought a subscription or for some IoT client talking to your endpoint, you can specify this usage plan based on this client TLS fingerprint. How you could do that? Of course, you need to add the API key, and I have two keys here, one for load test, and that's a popular utility. Of course, you're doing some load and performance testing, right? You can have it like a monthly activity, and during the release cycle, you can just remove them from the usage plan to prevent your environment being hit by some test traffic. We don't want this. Let's focus on my curl JA3 fingerprint. It's assigned to my test plan. This is my fingerprint, right? I have it here. And now what can I do with this? So according to my plan, I have a very specific throttling limits here. I have specified only 1 request per second. And on top of this, I went to my WAF and created a block rule, where in my block rule, I specified exactly the same JA3 fingerprint. And the lowest rate limit I could go to is 10, right? And it's only during 1 minute. So let's take a look what will happen if I will send somewhat like 20, 25 requests against my API gateway. Let me do this magic and do this.
We
Control
need a,
plus.
oh yeah, perfect.
Yeah. So you see, so when you send your requests, and there's 2 requests per second, it's throttled. When it's 3, it's throttled as well, and then I have 4. Why I have 4 here? What has happened? So the trick here is that, of course, when you run something in production, I lost my web page. I lost it. Here it is. When you run something in production, you probably want to mask your response codes. This is something which is working during large DDoS events, by the way. Whenever you got hit and there's some application impact, return 200 response, even though the origin returns an error. Then it doesn't give the attacker the possibility to understand how effective he is. And that's what I did on my CloudFront as well. I went to my distribution and I specified the custom response code. So in real life, what I do is I just redirect the users. Instead of giving him 4.3, I redirect to 4.4 page. That's it. That's the whole point. Now, the policy we specified, how all of this is working. How do we transfer this this JA3 fingerprint to the API gateway? Easy. We created this origin request policy. We specified it for a given behavior, right, for a given pattern. And on the origin request, we call Lambda at the edge. And this Lambda is very simple. That was a result of just occasional conversation with Alex. We just come with an idea, why don't we use the JA3 fingerprint as API key? And Lambda is really like, I don't know, 15 lines. What it does, it just takes the header value and rewrites X API key with that header value. That's it. That's how you forward this data. Now, when we go to API gateway logs, we can do this magic as well. Yeah, that's because I'm running different demos in different environments, so I have to refresh it. That's a pain. But yeah, honestly, showing here, it via command line doesn't make a difference.
While we're waiting, like, you know, isn't this like an example of really like a defense in depth strategy in using the WAF, using CloudFront, using API gateways quotas to like affect a solution, right? That has the outcome of like obfuscating what's going on for the attacker. We're able to get the quota mechanism, so we can ensure a certain amount of capacity is reserved for specific API keys, clients, right? And again, further obfuscate and still run all the negative filtering and the traditional stuff you do with WAF with this kind of scenario. So I don't know. I think it's a pretty cool solution.
And you're getting the lower rate limiting, right? Because it's the
Exactly.
API gateway that was doing the initial throttling, and then eventually you got to a point where the rate hit the WAF trigger, and that's where you started getting different types of errors. Out of curiosity, so to be able to provide the keys to the API gateway, you would obviously have to find out what is your JA3 fingerprint of the thing or device that's trying to connect, obviously, right? And then populate your API gateway configuration with appropriate details of, hey, here is an API key, but ultimately that's an identifier, JA3 derived identifier for each individual client.
Yes, that's true. So that's a hard piece where you need to hard code it, and eventually you hit the limit from the API gateway side where you have only limited amount of keys you can assign to the usage plan, and probably there is a way to work around that. And again, if
use multiple API gateways, route forward differently, scale it out a little bit more horizontally. There's a number of different approaches to like shard out an implementation like this, right? But to answer your question directly, Tom, like the way I've solved the like how do I get the what to put in their fingerprint in an easy way is typically what you do is you'd set up like a pre-production implementation or like a staging testing endpoint that you'd point your client at, whether that's via DNS or somehow get the request over to your pre-prod environment, which has a higher verbosity of logging, that then you can use that as like the key that you're going to leverage in the API gateway config. And of course, all that is like super scriptable, pick a IAC mechanism to, CDK or, and a little bit of log plucking, and you could, pick out the fingerprint that you put in there, right?
Yeah, makes sense. And from a use case point of view, are you guys thinking this is most applicable for when my devices are more IoT devices, or is it more when I'm a browser client? What do you guys see this as the best use case?
Well, I could give it 2 seconds. I'll give it 2 seconds, right? Which is so this is really applicable for like known like clients with known, like I'd say like if you have firmware, right, that you're putting out on device. So IoT, yes. But like IoT is a very large space. So I'd just say connected devices in quotes or smart devices. This would be a great mechanism to leverage because again, it's a very constrained use case in how they update, right? There's other trust mechanisms people use for IoT also that could shore up the trust to ensure that like the bad guys aren't getting in the middle and figuring things out. But I just say because of the like the greasing or the obfuscation of like how the browsers are trying to shuffle around stuff in JA3, it wouldn't be as applicable for browsers. I still use it as a mechanism to classify traffic, but I don't know that I'd use it for this particular use case. I don't know. Yeah,
because it would be too varied, right? It would be changing, like you guys were showing earlier. If like Chrome browser will keep changing per session the key, and it would be pretty much impossible for you to pre-populate all those keys. And do you guys think with JA4, once that's supported, would that make a difference? Because it sounded like, from what I understood from the JA4 explanation, that it's going to be a little bit more standardized in the way the hash is going to look like. Would that make sense to then have a key that may be derived from a portion of the JA4 hash instead of trying to have a unique one? You just have the like portion that's applicable to maybe majority of your devices.
okay, I'm gonna do it again. Or here, you want like here? Let me just do a little bit, right? Which is JA4 is really exciting, not only for the signatures, but there's like JA4 actually extends the kind of signatures that you can get in a more standardized way, right? So like it has a header mechanism. It has like you can fingerprint a lot more in JA4. And so, yes, I think it's going to be a much more solid signal to get from browsers and all kinds of user agents. So here, let me shut up for a second. I think I'm excited about JA4. I think it's going to allow a lot of capability.
I'm kind of thinking why we focus on identifying the user agents itself or browsers, because it's easy to fake. We have other mechanisms on the CloudFront to distinguish mobile client from other client as well. So probably it's really good working tool to identify some automations, some Node.js apps, some popular frameworks, Python application you wrote. Eventually, it will depend on ciphers supported by your OS at the end, right? And what you have in your search store locally. So these are the things where JA3 usage could shine. And of course, with JA4 adoption, it will give much more capabilities. You can just apply the similar workaround, the similar way on how to pass the key, just the key will be different. And as we saw on the slide, there will be different granularity. You can go down deep to filtering by separate extensions supported, protocol supported, HTTP version supported, and it's all together. There's a lot of already available resources across internet with the databases of known browsers, JA4 fingerprint. So yes, probably JA4 is an answer, interim answer, because again, this war is impossible to win. That's never-ending process.
I'd like to chime in just to explore this choose your own adventure path with bot control. One of the benefits is that you can use client SDKs, and we have two options. You can use JavaScript SDK or client SDK for mobile apps like iOS and Android. So the benefit of using this is that you can use a token, which is generated as part of request evaluation as your identifier as well. So you got many options. They could be JA3, they could be JA4. You can use a token generated by WAF, or you can use a combination of all those three. So yeah, just there's so many opportunities, and depends on your specific use case, and also depends on amount of times that you're willing to spend to implement and maintain the solution. You can choose the ways that you prefer, which could be utilizing various combinations of fingerprints or going with a managed solution where we do all the heavy lifting for you.
I guess the question with that would be which one of these things you can pull out to make it an API key for the specific solution that we're talking about, right? Because if you want to get that extra rate limiting on the API gateway, you gotta, I guess, pull out some information that you're going to use as that API key to limit your traffic.
That's a good question, because technically you could put the value of header count, put the value of, I don't know, the first octet from WAF token, or whichever you want to match, and combine it into one single lambda and forward it to API gateway for sure. But what Maxim said, it's excellent point, because at the end it's a question for solutions for non-browser based clients where JA3 really fits, and browser based clients where we really need to use WAF bot protection.
Yeah, I would just, if you're designing an implementation out there, I'm just going to ask you as a humble essay, please separate your traffic before you try to run it into an implementation. Meaning, like, it's much easier if you've got, like, on the ingress side of it, your mobile, your connected devices, your desktop, separated in such a way that you can, when you have everything going into one and you're trying to disambiguate and do treatments on each, it can get kind of complex quickly. So it's a really common pattern to have like mobile, web, and like different kinds of application classification on the way in, meaning separate host names, so we can try separate treatments on the kind of expected ingress we're going to see. So pretty please with sugar on top guys out there, please help us defend your implementations. And if you split it up, it'll be I think easier for everybody involved.
Sounds like you've seen implementation where that wasn't properly split up.
I mean, seeing it's really, again, when you're talking about, millions of requests in an hour, and you're trying to quickly classify what's going on an endpoint, it's really helpful to have, because again, Maxim kind of intimated towards some of the things we can do in the mobile space, meaning like for a true defense in depth, like, again, we're talking about a really unique solution to like use quotas and throttles and populate through dynamic values and lambda at edge, like a key that you can use to like let in a volume of traffic, right? But like in the mobile space, we've got an SDK, right, that can generate WAF tokens, and it's a very high fidelity signal that we can use for identifying mobile, that this is a trusted, like this is from your device, right? Or from a device that you've authorized through the SDK that's implemented on your app, right? And again, if that's like all coming through one channel, like you can have a different level of trust or risk around that then again, you might want to pay more attention to the web space or the wild web, where again, I do see attacks on mobile infrastructures or on mobile endpoints, but again, it's much easier to have separate streams when you're looking at like risk and classifying traffic to analyze what's going on in them.
Yeah, I guess even the classification itself, right? If you mixed it up and already on one endpoint, and then you have to classify and unmix it, that's a wasted time. If you could just have individual endpoints for different application types, I like that advice. Cool.
Yeah.
Well, this is probably it. I know we took much more time than it's anticipated, and these conversations we have, Max, Alex, every time we meet, it's a lot of interesting things coming, and we're happy to be here again. Tom, hope it's not the last meeting. Yeah. And thanks team, thanks Maxim for providing insights on the roadmap. It's very useful, and again, as I mentioned, that's the food chain we have. Customers comes to technical account managers works with service teams through our AWS PMs, and then we reach out Alex and his team for the tricky use cases. That's why he knows that you need to split your traffic.
Yeah, I mean, and I just leave with a couple other little thoughts, right? Which is, like 90% of what we build is based on customers' asks. And if you're not asking about it, we're probably not going to build it. So if you have a vision about what is possible, we are receptive and want to listen and execute. So please keep those ideas coming in our direction, because we want to provide a delightful, secure experience that's easy to use, right? And so I just ask, if you have ideas, please get them through people like us, so we can try to get them down to Maxim, so it can help us prioritize and execute on our strategies. If you guys aren't familiar, we have this thing called OP, right? There's lots of writing about it online, and we're getting into OP season now, which is our operational planning exercise. And so over the next couple weeks, I mean, we got reInvent just a little ways away, and we're all trying to get stuff done and out the door for reInvent. But it's what are we going to do next year is, I think, very salient topic right now. So if you got ideas, we're all yours. So here, I'll leave it at that.
And just to add to Alex, please keep the feedback coming. And our product teams, we're just a messenger and advocate for what customers really asking for. So it's how we operate. We just process all the feedback, and we're trying to advocate internally for certain features to become live, those that get the highest impact and most demand.
Awesome. Yeah, I don't think I've ever had it called a food chain, but I like it. I'll take it.
It's a lunchtime.
Yeah, it's
Fair,
lunchtime.
fair.
All right. Cool. Thanks. Thank you so much, guys, for providing the session, and thanks everybody else for joining. And join us next week for another The Routing Loop episode.